हेलो एवरीवन, स्वागत है आपका यूनिवर्सिटी एकेडमी यूट्यूब चैनल में। आज के लेक्चर में हम लोग डिस्कस करेंगे टाइम डोमेन रिस्पांस एनालिसिस ऑफ द जीरो ऑर्डर एंड द फर्स्ट ऑर्डर कंट्रोल सिस्टम। अगर आपको इन टॉपिक्स के हैंड रिटन नोट चाहिए तो जो लिंक है वो वीडियो के डिस्क्रिप्शन बॉक्स में गिवन है, आप वहाँ से जाके डाउनलोड कर सकते हैं। एंड वीडियो अगर आपको अच्छा लगे तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें। नाउ लेट अस सी द ट्रांजिएंट स्टेट एनालिसिस। ट्रांजिएंट स्टेट एनालिसिस इट डील्स विद the nature of the response of the system when subjected to an input, and it will depend on the order of the control system. In the previous lecture I have told you that signal it has two part, that is transient and steady state. When the transient die out, the circuit will reach to the steady state. Okay, so the transient response parameter they depend on the order of the control system, and steady state response parameter it depend on the type of the system. What is order? जो characteristic polynomial होता है उसमें जो s की जो highest power है it will give the order of the system. Okay, so it is obtained from the characteristic equation which is 1 plus gh is equal to 0. ओके, सो यहाँ पे जो s की जो हाईएस्ट पावर होगी दैट विल गिव द ऑर्डर ऑफ द सिस्टम, एंड टाइप इज ऑब्टेन फ्रॉम द ओपन लूप पोल्स लाइंग एट द ओरिजिन. ओपन लूप पोल्स चाहिए तो इसके लिए हमें क्या है, ओपन लूप ट्रांसफर फंक्शन चाहिए, दैट इज g ऑफ s इंटू h ऑफ s इन केस ऑफ यूनिटी फीडबैक. ओके, next point is transient response parameter. Transient response parameters are like we will calculate the expression for the delay time, rise time, peak time, settling time, and peak overshoot, that is MP. Okay, so these are known as the transient response parameter. All these parameters they depend only on the system. चाहे हम कोई भी input apply करें like step, ramp, parabola, तो इनका जो formula है for the first order and second order they remain the same. It means they are independent of input. Whereas the steady state response parameter, steady state response parameter is steady state error, that is represented by E of SS, that is steady state error. It depends on the system as well as on the input signal we are applying. We will discuss all these parameters in detail. First we will discuss zero order system. This order of the system it also gives us the information about how many energy storage elements are present in the system. जैसे अगर zero order है it means there is no energy storage element present in our system. Okay, so there is no energy storage element present. अगर फर्स्ट ऑर्डर है देन सिस्टम विल कंसिस्ट ऑफ ओनली वन एनर्जी स्टोरेज एलिमेंट, एंड अगर सेकेंड ऑर्डर है तो इट विल हैव टू एनर्जी स्टोरेज एलिमेंट, दैट इज इंडक्टर एंड कैपेसिटर. Okay, so no storage element is present in zero order system. We know that the generalized form of the transfer function, that is C of s by R of s, it will be given by, suppose the numerator is constant and in the denominator, the denominator of the closed loop transfer function it will give the characteristic polynomial. Suppose it is of the form a n s power n plus a of n minus 1 s power n minus 1 so on up to a1 s power 1, and then constant is suppose a naught. Okay, so this is general form of the transfer function where denominator this is indicating the characteristics polynomial. Okay, जीरो ऑर्डर सिस्टम का जो ट्रांसफर फंक्शन है इट विल बी ऑफ द फॉर्म सी ऑफ एस बाय आर ऑफ एस, इट विल बी इक्वल टू बी नॉट बाय ए नॉट. Okay, so this is the form of the transfer function for the zero order system. Suppose this b naught by k naught it will indicate the gain that is represented by k. Okay, so k is the gain. This is the transfer function for the zero order system. If we discuss about the example, अगर कोई भी energy storage element नहीं है so it means it will be a resistive network. Examples are zero order system is like potentiometer. Okay, so potentiometer or the resistive network. These are the examples of zero order system. We can represent this transfer function in the block form. Input is R of s and we are getting the output which is C of S, and we are getting K. So from here we can see that C of S by R of S is equal to gain of the system, that is K. Now next we will discuss the analysis of the first order system. So यहाँ पे क्या है कि जो order है वो first है, it means it will consist of one energy storage element. So suppose I am considering a network which is consisting of a resistor and one storage element, that is capacitor, that is RC network I have considered. Okay, so this is resistor and this is capacitor. So we are applying the input, suppose it is R of t, and we are taking the output which is C of t across the capacitor. So now if we find out the transfer function, that is C of S, then it will be equal to, so C of S by the voltage division rule we can find out that it will be equal to R of S into, so this is R of S into, so कैपेसिटर को एस डोमेन में हम रिप्रेजेंट करते हैं बाय 1 बाय एस सी. सो दिस विल बी इक्वल टू 1 बाय एस सी डिवाइडेड बाय सम ऑफ बोथ द इम्पिडेंस, दैट इज आर प्लस 1 बाय एस सी. सो फ्रॉम हेयर वी आर गेटिंग द ट्रांसफर फंक्शन, दैट इज सी ऑफ एस बाय आर ऑफ एस, it will be equal to 1 upon 1 plus SCR. Okay, so now इस सर्किट का जो टाइम कांस्टेंट है that is represented by T, it is given by R into C. So this will be equal to C of S by R of S is equal to 1 upon 1 plus S into T. Okay, so this is the standard transfer function for the first order system. Okay, so this is standard transfer function of first order system, where this T indicate that it is a time constant. Okay, so where T is equal to R into C, that is time constant. Now in the first order system we will apply the different input, like first of all we will apply the impulse, then we will apply the step input, then ramp, and then parabola. So now first of all we will discuss the impulse response analysis of the first order system. So हमने देखा कि जो first order है उसका जो transfer function है that is given by standard transfer function is 1 upon 1 plus S into T. Okay, so input we are applying R of S and output we are getting C of S. So C of S by R of S, it will be equal to 1 upon 1 plus S into T. So now we are applying the input, that is impulse input we are applying. So impulse, it is represented by delta of T. Okay, so R of T, it is equal to delta of T. So now if we take the Laplace transform of the impulse signal, then R of S, it will be equal to 1. So from here we are getting C of S, it will be equal to 1 upon 1 plus S into T. So R of S is 1, so this will be equal to into 1. Okay, so now अगर हम inverse Laplace transform apply करें, then we are getting the impulse response as, so this will be equal to 1 by T e की power minus small t by capital T into u of t. Okay, so we know that the Laplace transform of e की power minus at, it will be equal to 1 upon s plus a. Okay, so यहाँ पे सबसे पहले हमें t को constant लेना होगा, then it will be of the form 1 by s plus a. So उसका जो inverse Laplace transform लेने के बाद we will get the inverse Laplace transform in this form, that is e की power minus of a into t. Okay, so this is the impulse response for the first order, that is of the form 1 by t e to the power minus small t by capital T, where 1 by t, this is indicating the amplitude. Okay, so this is indicating the amplitude. So now if we plot this impulse response, then this is, on the x-axis we have time and on the y-axis we have impulse response. So अगर हम इस expression में t की value 0 put करें, then e to the power 0, it will be equal to 1 by t. This is indicating amplitude. Okay, so this is t is equal to 0 पे we are getting the amplitude which is equal to 1 by t, and if we substitute t is equal to infinity, then it will be e to the power minus infinity, which is 0. So it means it is becoming 0 at t is equal to infinity. Okay, so जो ideal curve है it will decrease like this. Okay, so this is ideal impulse response curve, but practically it will decrease exponentially and it will tend to become 0 at t tending to infinity. Okay, so this curve is practical and this is ideal. So for any system to be stable, the transient must die out so that the system can attain the steady state. So we have seen that as t is tending to infinity, our impulse response it is tending to 0. It means the transient are dying out and the system is attaining the steady state. Hence, for the system to be stable, the impulse response of the system must be absolutely integrable. Okay, so for the absolutely integrable signal, if we integrate from 0 to infinity, the magnitude of the impulse response, it should be less than infinity. Okay. Now therefore, for a causal LTI system to be stable, all the closed loop poles, that is all the roots of the characteristic equation, must be located in the left side of the S plane. Okay. So यहाँ पे क्या है कि जो हमारे closed loop poles हैं, that is nothing but the denominator polynomial. Okay, it if we solve then it will give the roots of the characteristic equation. So उसके जितने भी roots हैं वो क्या है, left half में अगर lie कर रहे हैं, then only the causal LTI system it will be stable. Okay, so this is S plane, that is sigma and j omega. So all the roots of the characteristic equation it should lie on the left half only. अगर एक भी root right hand side गया then that system will be unstable. And if the roots are lying on the imaginary axis, okay, and that will known as marginally stable system. Okay, so for the system to be stable, all the roots of the characteristic equation it should lie on the left side of the S plane. Now next let us see the step response analysis of the first order system. So we are having the first order system. इसका जो standard transfer function है that is 1/1 plus s into t. Now we are applying the step input. Okay, so that is r of s, output we are getting c of s. So we are applying the input, that is r of t, it is equal to u of t. So if we take the Laplace transform, so we are applying the unit step input, so it will be equal to 1 by s. Okay, so this will be equal to, so from here we can find the step response. So we know that c of s by r of s, that is transfer function, is 1/1 plus s into t. So from here we are getting c of s, it will be equal to 1/1 plus s into t. R of s value is 1 by s. So now we can solve this using the partial fraction. Then after applying the inverse Laplace transform, so we can write in this form, that is a by s plus b by 1 plus st. Okay, so if we substitute s is equal to 0, then we are getting a value as 1, and if we substitute s is equal to minus 1 by t, so b value we are getting as minus of t. And after applying the inverse Laplace transform, we are getting the step response of the first order system as 1 minus of e to the power minus small t by capital T into u of t. Okay, so this is the step response of the first order system, that is 1 minus e to the power minus small t by capital T. Okay, so this 1 is indicating that it is steady state response, this is steady state, and this is the transient response. Okay, this is the transient response of the first order system when we are applying the step input. So now if we plot this step response with respect to the time, then we are getting, so this is the step response expression which we have obtained, that is 1 minus e to the power minus small t by capital T into u of t. Okay, so now let us plot. So on the x-axis we have time, okay, and on the y-axis we are having the step response. So we have applied the input, that is unit step input. Okay, so unit step input, it means amplitude is 1. Okay, so now if we calculate c of 0, it means if we substitute t is equal to 0, then it will be equal to e to the power 0, which is 1. So 1 minus 1 is 0. It means c of 0, that is output at t is equal to 0, its value is 0. And if we calculate the output at t is equal to infinity, that is under the steady state, then e to the power, it will become minus infinity, and e to the power minus infinity is 0. So it means output at t tending to infinity, it will be equal to 1. So it means our step response, so t is equal to 0 पे उसकी वैल्यू कितनी है 0, and t is equal to infinity पे उसकी वैल्यू कितनी है 1. So अगर वो आइडियल है, that is ideal curve, if you are plotting, then it will increase linearly, but it is practical, so it will increase exponentially. Okay, so it will increase slowly and it will reach to the steady state. Okay, so let me draw again. Okay, so this is ideal curve, it will quickly reach to the final value, and this is practical. Okay, so now let us see the transient response parameter in this curve. So first parameter is delay time. So delay time, it is defined as the time taken by the step response to reach 50% of the final value. तो यहाँ पे final value कितनी है 1. Okay, so उसका 50%, that is 0.5. Okay, so that is, it will be somewhere here. So that is, it is 50% of the final value, which is 1 in this case. So that is known as delay time. Okay, so it is denoted by td. So td is the delay time, and it gives that the amount of the time taken by the step response to reach 50% of the final value starting from the 0. Okay, then we have rise time. So rise time, it is defined as the time taken by the step response to reach to the 90% of the final value starting from the 10%. Okay, so this will be the 90% of the final value. Okay, so this is 90% of final value, which is 1, but starting from the 10%. Okay, so this is rise time. So this is 10% of 1. Okay, so this time, it is known as rise time, that is t of r. The next parameter is settling time. So settling time, it is defined as a time taken by the step response to reach 2% of the tolerance band. It means अगर 1 final value, then suppose अगर 100 final value, then 98 to 102 value तक पहुँचने में जितना time लग रहा है, that is known as a settling time. Okay, so this is 1. So suppose that is plus minus 2% of tolerance band. So this much amount of time it is taking, so this will give the settling time. Okay, that is t of s. So here final value is 1, so it means 0.98 to 1.02 value तक पहुँचने में कितना time लग रहा है, that is given by the settling time. And the steady state response parameter is steady state error. So steady state error, it is the difference between the input and the final value of the response. Okay, and one terminology is time constant. So time constant, it is defined as the time taken to reach 63% of the final value. So this is somewhere 63% of final value. So this will give the value of the time constant, that is t. So this t, it is a system parameter. So now let us discuss the response parameter. So सबसे पहले उनके फॉर्मूले डिस्कस कर लेते हैं. सबसे पहले हमने डिस्कस किया था डिले टाइम. ओके, सो डिले टाइम, इट इज़ रिप्रेजेंटेड बाय td. सो जो फर्स्ट ऑर्डर है उसके लिए जो डिले टाइम का जो फॉर्मूला है, दैट इज़ गिवन बाय 0.7 इंटू टी. ओके, सो if delay time is more, then the system is more sluggish. It means TT, it is proportional to sluggishness. It means if the delay time is more, it means system is taking more time to reach to the 50% of the final value. This indicates that system is more sluggish, means system is slower. ओके सो अगर डिले टाइम ज़्यादा है, इट मीन्स हमारा जो सिस्टम है वो बहुत ज़्यादा स्लो है. एंड फर्स्ट ऑर्डर के लिए जो डिले टाइम का जो फॉर्मूला है, इट इज़ गिवन बाय 0.7 इंटू टी. ओके द नेक्स्ट रिस्पॉन्स पैरामीटर इज राइज टाइम, that is denoted by t of r. Okay, so its formula for the first order is 2.2 into t. second order के लिए different formulas हैं and first order के लिए different formula है. Okay, now rise time, it is inversely proportional to the speed. Okay, so if the speed is more, okay, so if the speed of the response is more, then obviously rise time, it means the time taken by the response to reach to the 90% starting from the 10%, it will be less obviously, क्योंकि speed अगर ज़्यादा है तो time कम लगने वाला है. So it means rise time, it is inversely proportional to the speed. Okay, the next parameter we have settling time. So this is settling time denoted by T of S. Okay, so depending on the tolerance band, we have the formula. So for the 2% of the tolerance band, so for the 2% tolerance band, the settling time is given by 4 into T. Okay, and settling time, it is inversely proportional to stability. So if the system is taking more time to get settled, that is it is taking more time to reach to the steady state, obviously stability will be less. Okay, so अगर settling time ज़्यादा है, मीन्स सिस्टम को बहुत ज़्यादा टाइम लग रहा है स्टडी स्टेट तक पहुंचने में, एंड ट्रांजिएंट जो है वो बहुत देर तक स्टे कर रहे हैं, देन ऑब्वियसली सिस्टम की जो स्टेबिलिटी है वो कम होगी. ओके, एंड देन फोर्थ पैरामीटर वी हैव स्टडी स्टेट एरर. So that is steady state error, that is E of SS. So steady state error, it is a difference between input and output. So we can write R of t minus C of t. Okay, it is also given by limit t tending to infinity E of t, and if we use the final value theorem, then it is given by limit s tending to 0 s into E of s. So this steady state error, it is inversely proportional to accuracy. It means अगर system में error ज़्यादा है तो obviously system की जो accuracy है that will be less. So that is why the steady state error, it is inversely proportional to accuracy. So this is the definitions of the transient response parameter which I have already discussed. So पहला क्या है, delay time है. So it is a time taken by the step response to reach 50% of the final value starting from the 0. Okay, and formula is given by, so delay time, it is equal to 0.7 into t. Okay, the next is rise time. So it is a time taken by the step response to reach to 90% of the final value starting from the 10%, and rise time formula is 2.2 into t. Then we have settling time. So it is a time taken by the step response to reach and stay within the specified tolerance band. Usually क्या है, 2% tolerance band question में given होता है. Okay, so for the 2% of the tolerance band, the settling time is given by 40. And suppose अगर 5% of tolerance band given है, then the settling time, it will be equal to 3t. Okay, so but generally क्या है, we use 2% of the tolerance band. And then last is steady state error. So it is the difference between the desired value of the response, that is input, and the final value of the response. So that is steady state error, it is the difference between the input and the output value. Next, let us discuss the ramp response analysis of the first order system. So this is the standard first order system transfer function, that is 1 upon 1 plus st. So input is R of s and we are getting the output C of s. So input जो हम अप्लाई कर रहे हैं वो है ramp input, so that is t into u of t. So now if we take the Laplace transform, then R of s we are getting 1 by s square, because we know that Laplace transform of t power n, it is given by n factorial by s power n plus 1. तो यहाँ पे t की पावर कितनी है 1, so 1 factorial is 1 by s square. Okay, so this is r of s. So from here, if we find out c of s expression, that is c of s by r of s, it is equal to 1 upon 1 plus s into t. So this implies that c of s, it will be equal to 1 upon 1 plus s into t into 1 by s square. So after solving this expression and by taking the inverse Laplace transform, then we are getting the ramp response expression as small t minus में capital T into 1 minus of e to the power minus small t by capital T into u of t. So this is the ramp response. We can expand it further, so this can be written as small t minus में capital T, this will become plus t into e to the power minus small t by capital T into u of t. So this small t minus capital T, this is indicating the steady state value, and this t into e to the power minus small t by capital T, this is indicating the transient state value. So this is the ramp response expression for the first order system. Similarly, we can develop the ramp response expression for the first order system. Okay, so now input r of t, it will be equal to t square by 2 into u of t. Okay, so this indicates the parabolic input. Now if we take the Laplace transform, then we are getting it will be equal to 1 by s cube. Okay, so now first order system में हम क्या है parabolic input apply करें, so r of s is 1 by s cube. So from here we are getting c of s, it will be equal to r of s into 1 upon 1 plus s into t. So this will be equal to 1 by s cube into 1 upon 1 plus s into t. So we can solve this using the partial fraction, then we are getting the parabolic response as t square by 2 minus of capital T small t minus में capital T into 1 minus of e to the power minus small t by capital T into, so this is u of t. So this is the parabolic response expression for the first order system. So हमने फर्स्ट ऑर्डर सिस्टम एंड ज़ीरो ऑर्डर सिस्टम को डिटेल में डिस्कस किया. इन द नेक्स्ट लेक्चर वी विल डिस्कस द टाइम रिस्पॉन्स एनालिसिस ऑफ द सेकेंड ऑर्डर सिस्टम. तो अगर आपको वीडियो अच्छा लगा हो तो प्लीज़ वीडियो को लाइक एंड शेयर ज़रूर करें. थैंक यू फॉर वॉचिंग.